Hello, everybody. My name is Angad Arora, and I wrote a literature review research paper on aluminum-ion batteries, and now I'm presenting aluminum, the future of battery technology. So, just a quick agenda. We'll start with the introduction, then a comparison of aluminum-ion and lithium-ion batteries, the current challenges with aluminum-ion batteries, and recent and ongoing advancements. Finally, we'll end with applications and a conclusion. All right, so a quick overview. Lithium-ion batteries, also abbreviated LIB, have dominated the battery industry because of their superior electrochemical characteristics. Aluminum-ion batteries are gaining attention for their potential to offer sustainability advantages over LIBs. Yet, challenges still exist with current aluminum-ion batteries, but technology advancements place is closing with the gap with LIBs. And AIBs show promise in surpassing LIBs, prompting exploration into their capabilities and applications. Overall, my research aimed to find a new battery technology that was more sustainable than lithium-ion batteries. All right, so let's quickly talk about how a battery works. A battery consists of three main components: the anode, the cathode, and the electrolyte. Here's a simple breakdown of how these parts work together. Anode is the negative side. This is where oxidation reaction takes place, releasing electrons to the external circuit. The cathode is the positive side. Here, a reduction reaction occurs, accepting electrons from the external circuit. Finally, the electrolyte. This medium allows ions to move between the anode and cathode. All right, let's compare aluminum-ion batteries and lithium-ion batteries. Aluminum-ion batteries, the chemicals they're made out of is aluminum, and they have a trivalent aluminum ion. Additionally, to charge, the aluminum ion migrates from the anode to the cathode, releasing electrons, and to charge, there's reverse migration. Right now, its market reach is an emerging battery technology, and it's a rising contender for sustainable energy storage. Lithium-ion batteries. On the other hand, lithium-ion batteries have a graphite anode and a metal oxide cathode. To discharge, the lithium ion intercalation into the cathode, which releases an electron. To charge, there's reverse movement of the electron. And its market reach, as of today, it's the primary dominant battery technology in all applications. But its sustainability is limited. All right, a few more differences. Aluminum-ion batteries have a trivalent aluminum ion, which has a +3 charge, whereas lithium has a +1 charge. Trivalent ions offer higher energy storage capacity, improved conductivity, and faster ion mobility. So, overall, AIBs have a better battery performance in this aspect. Let's talk about some structural differences too. During charge and discharge, LIBs involve the intercalation process, whereas AIBs primarily witness the plating of aluminum ions onto or stripping from the metal anode. This is one con in aluminum ions, as stripping and plating can degrade battery life. All right, some cost considerations to keep in mind. Aluminum costs $2.55 per kg, whereas lithium costs $18.75 per kg, which is almost 7 times costlier. So this has a lot of economic implications and problems in the scale-up potential. So the material requirement. Aluminum-ion batteries employ carbon-based materials such as graphite for cathodes, and they don't use heavy metals like cobalt, which are not sustainable. On the other hand, lithium-ion batteries utilize metal oxide cathodes, such as cobalt, nickel, and manganese oxide. All right, resource extraction. Aluminum is the third most abundant element in Earth's crust, comprising nearly of 8%. Lithium, on the other hand, only makes up about 0.002% of Earth's crust by mass, indicating its scarcity. Aluminum can be recycled 50 to 70 times, compared to less than once for lithium, reducing the need for primary extraction. Additionally, lithium uses significant water during extraction, which causes stress in regions such as the Lithium Triangle and Australia. All right, so overall, aluminum's abundance and cost efficiency makes it way more sustainable than lithium, and it's abundantly available in the Earth's crust. Additionally, it's significantly cheaper, so scale-up potential will be way better. Aluminum-ion batteries offer a more environmentally friendly alternative due to the abundance and cost-effectiveness of aluminum. While aluminum-ion batteries are significantly more sustainable than lithium-ion batteries, The main reason they have not been adopted yet is due to their subpar electrochemical performance metrics. All right, let's talk about some challenges with aluminum-ion batteries. They have a lower voltage, lower discharge rate, and their electrochemical complexity makes it hard for companies to produce them in mass. All right, so what efforts are going on by scientists today to make aluminum-ion batteries able to compete with lithium-ion batteries in the electrochemical aspects? So here's one of 4 new types of aluminum-ion batteries that I have researched. It is called the molten aluminum chloride urea graphite battery, and its unique electrolyte allows it to have a high electrochemical capacity with 99% retention after 500 cycles. Next is the super long life aluminum battery. It uses CMK3, which is an ordered mesoporous carbon cathode, which is super sustainable, and its cycle life exhibits over 36,000 charge-discharge cycles with negligible degradation. Another battery technology is the high Coulombic efficiency aluminum-ion battery. It has a really proprietary blend of the electrolyte of aluminum chloride in a 1.3 to 1 molar ratio to improve discharge rate and Coulombic efficiency. Finally, the ultra-fast all-climate aluminum graphene battery overcomes the challenge of low voltage compared to lithium-ion batteries by focusing on discharge rate enhancement through a graphene film cathode with tri-high, tri-continuous design. All right, so here is a graph showcasing different types of battery technologies. So all the way on the left in the red is a normal aluminum ion battery, and in the orange is a normal lithium ion battery. As you can see, the blue circles, purple circle, and yellow circle show the new advancements of battery technologies that I talked about, and how their cycle life and Coulombic efficiency far exceeds anything of lithium-ion batteries. Now let's talk about the applications of aluminum-ion batteries. The main uses of battery technology are energy storage systems, electrical vehicles, and portable devices. All right, so here are just the requirements in electrochemistry metrics for each type of application. So aluminum-ion batteries can be applied in energy storage systems. The remarkable cycle life of over 36,000 charge-discharge cycles makes them perfect for things like battery power plants and cars. EVs is also a great place to use aluminum-ion batteries, as their high specific capacity of around 120 milliamp hours per gram ensures substantial distance coverage. Also, aluminum-ion batteries are far less susceptible to going up in flames, and they're less of a fire hazard than lithium. Finally, portable devices. The high Coulombic efficiency of nearly 99.7% ensures effective energy utilization in aluminum-ion batteries. All right, conclusion. Aluminum-ion batteries present a dynamic landscape of advantages and challenges, with ongoing innovations to revolutionize electrochemical energy storage. Their sustainability and safety benefits contribute to their potential as safer and more environmentally friendly energy storage solutions. All right, thank you. These are my references. And any questions?
Thank you very much. A couple questions coming in. So first question, probably the simplest. What initially interested you in battery tech as a focus of your research?
So I took AP Chem last year, and my teacher, around that time, China had took control of one of the world's largest lithium mines, and my teacher was telling us about how lithium-ion batteries are huge in today's world, and them taking over that huge lithium mine would mean a lot of profit. And he said if anyone can come up with like a contender for lithium ion, it would be really disruptive in the market space. So that's why I chose to pursue battery technology.
Yeah, very cool. So, so really just more for geopolitical reasons, to see if can kind of balance out the influence of the political powers that control lithium.
And sustainability for sure, yeah.
Love that, it's great. I think this is a clarification on one of the first points you made, but how does the trivalency of the aluminum batteries actually improve the battery performance?
All right, so when the battery is discharging, when it has a a trivalent ion moving through the electrolyte, that means there's actually more charge being distributed throughout the circuit, which would mean higher efficiency, a faster charge rate, and overall better cyclability of the battery.
Got it. And then last question. So you mentioned some of the challenges preventing aluminum battery development and some potential solutions. I'm curious how likely it is, do you think, that those challenges are going to be overcome, and what timeline do you anticipate those challenges will be overcome if they can?
Yeah, for sure. So I talked about 4 types of new proprietary aluminum ion batteries which are being developed as we speak. And those have been very expensive to develop, but I think over maybe the next 5 to 10 years, the cost could be cut down, and those could be turned into, they could be adopted by the world.
Perfect. Thank you very much for your presentation. This is really great.
Thank you.